Hello there. The next question now is about an absolute value or a modulus. To answer this absolute value, it might only take about 2 to 3 minutes, but it's not what I show you now to quickly answer it. Instead, let's briefly understand what an absolute values are. This question is a multiple choice question. It says, what is the solution set for an equation 3 times an absolute value of 2x minus 4 is equal to 6 minus 2 times an absolute value of 1 minus 5x. Choices are given here. But let's solve how we can reach into the correct answer. An absolute value is how far a given number or expression is away from zero. Here, it's only we consider the magnitude. The direction does not matter. It means that the negative signs are not important here. We only count the number of steps. Let's see here. We have on this number line 0. From the right of 0 is we do have a positive values. Let's step 3 here. 1, 2, 3. How much of these steps we've completed? 3. So an absolute value of 3 is just 3. The same thing here. When we move on the left side, 1, 2, 3, we reach into negative 3. An absolute value of negative 3 is, again, how many steps we covered. That's just 3. So an absolute value of a number or an expression is just the positive part of it, or just a positive number or expression. But what does it mean by a positive number? When we have a negative number, to make it a positive number, we need to multiply it by negative. This is the important key here. When we have a positive number, the absolute value of the positive number is just the number itself. And for 0, just 0 itself. For any number which is an element of real number, an absolute value of the number is just takes the number if it is positive. Again, an absolute value of a number, just take it as it is if it is 0. The last thing, which is important one, is an absolute of a number, just multiply it by negative if it is less than 0. Less than 0 means if it is negative. If the number is negative, multiply it by another negative, so that you can reach into a positive result. That's it. So an absolute value of minus 3 is just multiplied by negative, then it will be a plus 3. An absolute value of 5 is 5, an absolute value of 0 is 0. It's just what the definition of absolute value is. So, as a summary of this point, we can say that an absolute value or a modulus is how far a number is from 0. It is just only how far, the distance. So, it is always positive. Let's go for the next page here. And hence, absolute value or modulus of any number or a mathematical expression is always positive. We will see, when I say here, a mathematical expression, there might need a little bit of explanation then. That's what we are going to do now. Here we are given an expression in an absolute value, which is an absolute value of 2x plus 1. An important thing here is to find a critical point of this expression. A critical point of an expression means the point where it is 0, the x value where it is 0. From 0, on one side, it's normally positive, and on the other side, it's normally negative. The next thing is to identify in which regions it is positive and in which regions it is negative. This is all about a linear absolute value. Just to find out the 0 of this expression, for now, we ignore the absolute value symbol, and let's just take the expression 2x plus 1. 2x plus 1 is equal to 0 when 2x is equal to minus 1. It is where x is equal to minus half. Now we have minus half is a point where this expression gives a result of 0. On a number line, let's just highlight here that the place where the first one is just the number line itself. We can see that here. On the number line, we just put a 0. That helps us to get references. Which side are negative numbers, this way, and which side are the positive numbers of 0. But 0 here is not the 0 of the expression. The 0 of the expression is minus half. The expression 2x plus 1 is equal to 0 when x is equal to minus half. When we put minus half in place of x here, we're going to have minus 1 plus 1, which is 0. So this is the 0 of the expression. Once we have the 0 of the mathematical expression, we need to know which side it is negative, which side it is positive. Normally, expressions are negative on the left and positive on the right when they have the coefficient is positive. Here, 2x plus 1 is having a positive coefficient. So it's normally just acting like any other number. On the left, negative. On the right, positive. When we have an expression such as 2x plus 1, this changes where it will be positive and where it will be negative. It takes the positive part as negative and the negative part as positive. We can try this one later, but for now, let's just focus on the equation we have, which is 2x plus 1. Let's do a testing point, one point on the left side of the 0, which is not 0 of a number line, the 0 of the expression. The 0 of the expression is minus half. When we go to the left, we can have minus 1 here. We can test minus 1. This is one testing point. When we go to the right of minus half, we can simply find 0 here. 0 is another testing point. When we put 0 in this expression 2x plus 1, 2 times 0 is 0, plus 1 is 1. It is positive. So just on the right of minus half, this way, we have positive regions. What will happen on the left side? When we take minus 1 as a testing point, 2 times minus 1 is minus 2. Minus 2 plus 1 is minus 1. So on the left of minus half, it is negative. So this expression has two regions. One is left of minus half, this way. The other one is to the right of minus half, that way. So on the left of minus half, because it is negative, by definition of absolute value, we need to multiply it by a negative to get a positive result. On the right side of this expression, where it is the right side of the minus half, because it is just a positive number, by definition of absolute value, we take it as it is. This is a simple technique of getting a critical number, identifying negative region and positive region of an expression. This is just an example here. When we go to the main question, it will help us a lot. Now, we are back to the original question. The original question is having two absolute value expressions. One is here, an absolute value of 2x minus 4. The other one is an absolute value of 1 minus 5x. We can say a little character of this equation now before we go to identify the critical point and the negative and positive regions of this equation. We can see the leading coefficient of x in the first expression here is 2. 2 is positive, so it's taking the natural negative position, which is on the left of a number line, and the positive region on the right of the number line. On that number line, we need to find out first the 0 of this expression, and to the left of that, it is just negative. To the right of that, it is positive. We can see the other expression here. It's having a negative leading coefficient, which is -5. It's taking the other way around instead. Once we get the 0 of the expression 1 minus 5x, on the left side it's going to be positive because it has a negative in it here as a -5. Then the negative side will give us two negatives as a positive. The right side of the 0 will give us a negative. But we will further see it here. Let's find out first the 0 of 2x minus 4. The 0 of 2x minus 4 as 2x minus 4 is equal to 0, 2x is equal to 4, x is equal to 4 over 2, x is equal to 2. 2 is the 0 of the expression, 2x minus 4. Let's just show 2 on a number line, which is here. Now we need to take two testing points, one on the right side of 2, the other one on the left side of 2. Normally 2x minus 4 is having a positive leading coefficient, which is 2. Negative side has to be negative, and then the left side has to be negative, and the right side has to be positive. But let's do a testing point. A number which is on the left of 2 is, say, 1. Let's take 1 as a testing point. At 1, when x is equal to 1, 2 times 1 minus 4 is equal to -2, is negative. Let's take another number on the right side, say 3. 2 times 3, 6 minus 4, 2, which is positive. So the first expression, which is 2x minus 4, takes negative on the left of 2 and positive on the right of 2. That's what is indicated here. Let's now see the other expression, and we do the same thing what we have done here. The main steps are: find a critical point or a 0 point, take one testing point on the left of the critical point or the 0, take another testing point on the right, and find out which one is negative and which one is positive, and show it on the number line. That's what we do. So 1 minus 5x is equal to 0, 1 is equal to 5x, then x is equal to 1/5. 1/5 is the critical point, a point where the expression is 0. Let's look at 1/5 on the number line. 1/5 is just between 0 and 2, we can say. We can also say between 0 and 1, but let's take this one to be 1/5 at this point. Once we have 1/5, what we have on the left of 1/5 is 0. That's this one here. What we will have on the right of 1/5 is 1, somewhere here. So when we take 0 on the expression, this is here. When we take 0 on the expression, 1 minus 5x is just positive 1. When we take 1 in the expression, 1 minus 5 times 1, which is 1 minus 5, which is -4, negative. On the number 1 side, it is negative. On the 0 side, it is positive. So this expression is from a critical point here, to the left is positive, and to the right is negative. Now, we are having three regions here, if we can see it. Maybe not clear, that doesn't matter. What are the critical points which we have to focus on? One is number 2, and another one is 1/5. When we have these two critical points, how many regions we can create on a number line? One region from -infinity, from the left all the way up to 1/5. The other region from 1/5 up to 2, and the third region from 2 up to all the way to the positive infinity. These three regions cover all real numbers on the number line. So we need to have the regions where the character of these absolute expressions change, a positive or a negative. Based on these regions, we need to calculate region by region, creating into dividing that thing into three cases. Case 1, all the way from negative infinity up to 1/5. Case 2, between 1/5 and 2. And case 3 is from 2 all the way to the positive infinity. What's happening between negative infinity all the way to 1/5? 2x minus 4 is negative. This one here. 2x minus 4 is negative. 1 minus 5x is positive. So in this part, 2x minus 4 is negative. Here, 1 minus 5x is positive. This first case. In the second case, in between 1/5 and 2, 2x minus 4 remains negative, but 1 minus 5x will change because 1/5 is its critical point. Then it changes from positive to negative. So in this region, we have both expressions to be negative. Then the other part, the third part, 2x minus 4 changes now to positive, but 1 minus 5x has already changed once, and it won't change again. It remains negative. So this is the thing, minus, plus, minus, minus, and plus, minus. Three combinations we get from two expressions. Why we need this? We'll see it. Just to revise back again what we have said earlier, an expression 2x minus 4 is negative all the way up to 2, and an expression 1 minus 5x is positive up to 1/5, and it becomes negative afterwards. So because of these characters over the critical points of 1/5 and 2, we create three regions. This is region 1, this is region 2, and this is region 3. These regions will be cases to solve our equation later on. In these regions, we can create cases. One case here, case 1, from negative infinity all the way to 1/5. We can include 1/5. Case 2, from 1/5 up to 2. This includes again 1/5 and 2. I'm putting this closed bracket. Inclusive bracket is because we are working on equalities, equal sign. So this includes the critical point to see if it is a solution. In case of inequalities, we might need an open bracket, which means will not include the boundary, the last number. Now let's include 1/5 and 2 in our cases here. The third case is from 2 all the way to positive infinity. So what are the characters of the expressions in these cases or regions? And then based on that, we put the equation within the region. When we get a solution set within that region or case, we need to check it back again if it is member of that region or domain. If it's not member of that region or domain, we will not accept. That is the next thing which we are going to do. Okay, in case 1 or region 1, 2x minus 4 is negative, and 1 minus 5x is positive. That's what we do. We put negative for 2x minus 4 because it's negative region. We need to multiply it by negative to get a positive result. That's the meaning of it, actually. Okay, 2x minus 4 is negative. 1 minus 5x is positive. Because 2x minus 4 is negative, we need to multiply by negative. We just put a negative in here. It's much easy. When we see a negative number here, we just put it to the expression. I'm trying to explain what's the meaning behind. The meaning behind is when it is a negative number, by definition of absolute values, we need to multiply it by negative to get a positive result. That is the meaning of it. In our expression here, in our calculation here, it is we simply put negative when we have a negative here, and then we just take it as it is, positive when we have a positive here. Now let's do the three equations in the three regions. For the case 1, 2x minus 4 is negative. It's here, negative is there. But 1 minus 5x is positive. There is nothing there. So let's express this one to make it more simple. Let's simplify. 3 times negative 2x minus 4 is equal to 6 minus 2 times positive 1 minus 5x. We don't have anything in there. Now, 3 times, because I have a negative here, we need to transpose this one. 3 times 4 minus 2x. Why we have to transpose it? Because when we have a 2x here, multiplied by negative, it becomes negative 2x. When we have a negative 4 here, multiplied by negative, it becomes 4, positive 4. So it means, in other words, we transpose. So 3 times 4 minus 2x is equal to 6 minus 2 times 1 minus 5x. This is the first equation for this case region. On the second region here, both are negative. So I have 2 negatives in here. Then I simplified to have this one. In the third region, 2x minus 4 is positive. 1 minus 5x is negative. So here is a positive. And here is a negative. So a little bit simplifying. This one will give me 3 times 2 minus 4x. 3 times 2x minus 4 is equal to 3 times 2x minus 4 is equal to 6 minus 2 times 5x minus 1. So now I have 3 equations in 3 cases or regions. The important thing is that in which region is an equation belongs to. So within that equation, once we solve and get a number, we have to make sure that it is a member of the region or the domain. This is a key point here. So here are the 3 cases. Case 1, from negative infinity all the way up to 1/5. The equation is here. 3 times 4 minus 2x is equal to 6 minus 2 times 1 minus 5x. When we simplify, we will have the value of x as half. How to simplify this one in a step-by-step lecture is found in the lectures section of this YouTube channel. We can go and see how to solve linear equations. That will help a lot. So now we have x value here as 1/2. Is 1/2 member of the case region or the domain? Is the question. The answer is no. 1/2 is not in here. These are all from minus infinity up to 1/5. 1/2 is greater than 1/5. It's just out. So for that reason, in case 1, we don't have a solution set. In case 2, from 1/5 to up to 2, this is the expression. We set up it earlier on the previous page. What we get from here is x is equal to -1. Is -1 a member of this domain? -1 from 1/5 up to 2? No, because these are all positive numbers, and then we have a -1 here. So -1 is not a member of this region, and then it is not a solution for this equation. We can substitute and check on the original. That's true. It won't be the solution. Let's see now region 3. Region 3 is from 2 up to infinity. The equation given for that on the previous page is this one. When we solve this, we're going to get 5/4. 5/4. X is equal to 5/4. Is 5/4 a member of this region? Is a question. Again, 5/4 is 1.25. It is less than 2. It's not a member of this domain or region. Then it's not a solution. So in these 3 cases here, we don't get any solution for the equation. So now we know that the solution set for the given equation is an empty set. Now we know that. But what are these numbers? One is here, 1/2. Another one is -1 here. -1, 1/2, and 5/4. What are these numbers, in fact? Let's go to the question and see what are they. Should we take all this time to answer this question? In fact, no. So how we deal with absolute value questions then? Let's see that. So those numbers which are -1, 1/2, and 5/4 are those numbers. It seems they are part of the solution set, but they are not within the given range or domain. So in absolute value questions, we have to check our solutions if it is part of the domain. If we have to check then on the question itself, in which we are given only 2 to 3 minutes to answer, we need to have a systematic approach for it, and then we have to carry on to the next question. We cannot stay here for 10 or more minutes, and then we will not have enough time to solve other simple questions in the exam. So what we have to do is, let's see, in choice A, we have 1/2 and 5/4. In choice B, we have -1, 1/2, 1/2 and 5/4. In choice D, we have -1 and 1/2. So we have 1/2 in 3 places. So it is just a systematic approach to try 1/2 if it works or not. If 1/2 is working good, the next thing to check might be 5/4. This is to use a technique of elimination. If 1/2 is not working, that means choice A is not answer, choice B is not answer, as well choice D is not answer. So that eliminates 3 of them in one shot if it is not a solution set for this question. So let's just put 1/2 in here. We can check it carefully here. When I put 1/2 in here, I'm going to have number 1 in this side. So 3 times 1 minus 3 is just 1 minus 4 is just -3. So on this side, I'm going to have 3 times -3. 3 times -3, absolute value of -3, which is also 3. So I am having 3 times 3, which is 9 on the left side. With 1/2, I have 9 on the left side. What about on the right side? On the right side, 6 minus 2 times an absolute value of whatever. An absolute value of whatever. Why I'm saying whatever is because whatever absolute value will give me positive here. Positive times -2 is negative. So I'm going to take away from 6. I'm not increasing 6 anymore. I'm decreasing 6. So I already have 9 on the left side, and I'm going to have less than 6 on the right side. These two numbers cannot be equal. So I can see that 1/2 is not the answer. Then the correct answer is C. This is all about the algebraic approach of this question. What does it mean by geometrically? Or what's the geometrical implication? I'm always more interested in the geometrical implication of any algebraic expression. So let's go and see this question geometrically in something which we can see. Okay, we are here to see the geometrical implication of this question. The question was saying 3 times an absolute value of 2x minus 4 is equal to, this is here, the other part of the question is here, is equal to 6 minus 2 times an absolute value of 1 minus 5x. So the question has 2 parts. One part is 3 times 2x minus 4. The other part is 6 minus 2 times an absolute value of 1 minus 5x. We can split them into 2 parts. One is as a function f of x is equal to 3 times 2x minus 4. The other is another function g of x is equal to 6 minus 2 times 1 minus 5x. Once again, to plot such graphs, it's important to know and understand linear equations and graphs. So this one is also covered again in another part of this channel. We need to understand that. Now, these functions f of x and g of x are equal. That is what the question says. Two graphs are equal means the two graphs will have an intersection point. That's the meaning of two graphs are equal. Two graphs are equal or two equations are equal means once we solve the equation, the number we are getting is an intersection point, nothing else. For example, I'm just giving example. If I say 2x plus 2 is equal to 4x minus 1, I'm saying I have a graph 2x plus 2 and I have another graph 4x minus 1. Do I have an intersection point for these two graphs? That's what I'm asking. So the number I get is the x value. Putting that x value in one of the two will give me a y value. The x comma y is a point of intersection. I can just solve this one to make things more clear. So this one say 2x plus 2 is equal to 4x minus 1. Let's equate them together. 2x plus 2 minus 4x plus 1. These two. Because I'm moving all of these parts to the left, I have just only 0 on the right side now. Now I add 2x and minus 4, which is minus 2x. I add 2 and 1, which is 3, is 0. Now, I make these two equations as a simple and 1 here. Now, I get a reference. What does it mean by actually 2x plus 3 is equal to 0? It has a meaning as well. It means here, these two graphs do have an intersection point. Then I'm given two graphs, say this one and this one. Do they have an intersection point? This is what it is asking. If I get that intersection point, I plot down to the x-axis, and this is the answer. This is the x value. This x value will have a corresponding y value. That's how it is. The graph might be somewhere else. Instead of I am working on the intersection of the two graphs, I come up to check it with that of this value directly. This value in terms of some other line or linear line, which is 2x plus 3. That means the other part is 0 means y is equal to 0, which is the x-axis. Now, I'm just getting this line with respect to 0, which is the x-axis. Y is equal to 0 over the x-axis. So 2x minus 2x is equal to minus 3. X is equal to minus 3 over 2. Now, once I have this number, it is the x value of the intersection. The corresponding y value of this intersection can be obtained by replacing this x or that x by minus 3 over 2. I can take any one of them. It should give me the same result, the same y-axis. Because this is the intersection of both lines, then this y is the same for both. Just this is the idea. Now once I have this one, let's just go back to our original question here. It says two absolute values are equal. These are, one is here, 3, an absolute value of 2x minus 4 is equal to 6 minus 2, an absolute value of 1 minus 5x. These two are equal. These two are equal means they have an intersection point. No, we don't have an intersection point for these two. Then the answer is again an empty set. But how do we plot them on a number line to decide on this. It's also another part of the discussion. We can have a look on that. For the function f of x is in here, f of x is equal to 3 times an absolute value of 2x minus 4. We can see that an absolute value of a number or an expression is always positive. So this graph, f of x, cannot have a negative value or negative y value. So it will never go back here in this region. So the green one is always above the x-axis. It will always have a positive result. How we know that one is just the same as the concept of a quadratic graph in which the leading coefficient is positive and it opens upward. The same thing here. 3 is positive. Then this absolute value graph opens upward. Okay, it opens upward, but what is the minimum point it will go down? This one here, the minimum we can achieve here is all positive, but the minimum is 0. So that minimum value is 0, then 0 times 3 is 0. The minimum value we can achieve is y is equal to 0, or the x-axis here. Now we know that the minimum value is the x-axis itself. It cannot go below the x-axis. But how do we know it is exactly touching number 2 instead? For that one, to find out an x-intercept, we need to give the value of y as 0. Y is the function output here. 3 times 2x minus 4, an absolute value, is equal to 0. This is where it touches. So divide both sides by 3. Then 2x minus 4 in absolute value is equal to 0. By absolute value definition, it actually gives 0. It doesn't matter. We cannot say now here a negative 0, a positive 0. Then this part, 2x minus 4, should be 0. By absolute value definition, it is 0. We take it as it is. When the absolute value output cannot be negative at all. If we have a negative value here, that's another thing. The equation is going to be an empty set. Again, we don't need to worry much on that one. Here we can see 2x is equal to 4, x is equal to 2. So the value of x where this function touches the x-axis is at x is equal to 2, y is equal to 0. And then it goes open upward. The other question again is going to be like how wide it is another question. How wide it is? Is it like this wide or that wide or this wide? This part is also covered in this section of the slope of a linear equation, the gradient or the slope. Now here, when we don't consider the absolute value, f of x is equal to 3 times 2x minus 4. F of x is equal to 6x minus 12. This part here in linear equation y is equal to mx plus b, which has been covered again in another section. This part is the slope of the graph. The slope has a gradient of 6, means the y increase is 6 times, while the x increase is only 1 time, 1, 6. We can see here, consider this part here. 1, 2, 3, 4, 5, 6 y's for only 1x. This is how it is. This is how it is. The same analysis can be done on the other function, g of x. Now look in here. This part is g of, the slope is 6 here. If the slope is not 6, say it is 5, it becomes a little bit wider. When the slope is 4, a little bit wider. It keeps being wider and wider. When I have in here, instead of 3, say I have 1, which is absolute value of 2x minus 4. There is no 3, then f of x is equal to 2x minus 4. We'll have a slope of 2. When we have a slope of 2, 2y increase for 1x increase. Then from here, it's coming somewhere here. Look at it. This way, this way, this way. Now it's gonna have two solutions. There's an intersection. So when we remove, for example, number 3 from the original question, I'm just giving an example, we're gonna have two solution sets for sure. We're gonna have two solution sets. There might also be an option in which we can have only one solution set when it is just only touching it here at the tip, right there. So two absolute value expressions as a graph. One is upward and the other one is downward. The maximum number of intersection we can obtain is 2. Whatever we do here, we cannot give more than 2 as an intersection, whatever wide it is. Here 2, here 1, this one also can come wider like that. So the maximum number of intersections we can achieve is 2. The minimum is just 1. 1 like this here. We can see here it's only 1. Or we can have also the other one somewhere here. It's also 1. We can have also one wider equation here, covering one narrower absolute expression here to have only one intersection point. So we can have a solution set as 1 or 2 of them. Let's talk a little bit about, again, the characteristic of g of x, which is 6 minus 2 times an absolute value of 1 minus 5x. Okay, g of x is 6 minus 2 times an absolute value of 1 minus 5x. In this one, because it is a negative coefficient here in front of the absolute value, the graph will open downwards. But if it opens downwards, it will go indefinitely. We cannot give the minimum value, or we cannot talk about a minimum value. But we can only talk about the maximum value where it can reach. For that, because we are going to subtract this value from 6, we need to know what is the smallest subtraction we can make from 6. That is possible only when we have an absolute value of 1 minus 5x as 0. Because anything other than 0 of this expression will be a positive as it is an absolute value. And when we multiply it by minus 2, which is out of the absolute value here, it becomes a negative. A negative number to be added on 6 means we are subtracting from 6. So that will not give it any more higher. So the 0 is the maximum the whole function can reach, or the minimum we can get out of the absolute expression. When we take 0 from here, 0 times 2 is 0. 6 minus 0 is just 6. 6 is the maximum value we can achieve as a y value here. That's what it is. From 6, it goes downwards. We can get the corresponding value of x for y is equal to 6 if we require it. We just only put 6 in front of here, and then we solve that part. That is not important for now, or probably we can do that now. And it is itself is self-explanatory in such a way that the maximum value y is obtained by putting this absolute expression as 0. This is what we said. So let's take up at 1 minus 5x is equal to 0, which means 5x is equal to 1, x is equal to 1/5. If we need to know the corresponding x value, which we don't need it, we can say 1/5, 6. This is a point where the maximum is achieved. But when we say about maximum and minimum, we are interested in the y values, the corresponding y values instead of being the x values. So this is how it is. Now, this graph is having what slope is the next question. This graph, as it goes down, the graph of g of x, as it goes down, it keeps far and far away from the graph of f of x. That is because of the slope or gradient of this graph. Normally, the parabolas as well as the absolute value of graphs are symmetrical with a line of symmetry that divides them into two parts on the left and right side. It is there. They are symmetrical graphs. So we don't need to worry about a place where the absolute value of 1 minus 5x gives negative, and then we have to multiply by negative. No, just only to find the slope of this graph, we can just take it as it is by removing the absolute value symbol and replacing it by just simple brackets. So g of x is equal to 6 minus 2 times 1 minus 5x. G of x is equal to 6 minus 2 times 5 plus 10x here, which is equal to 4 is there plus 10x. Something like this is what the graph looks when we consider the linear part on one side of it only. The slope of the graph is 10. Okay. Here 10 means the gradient of the graph in which the change of y into the change of x is equal to 10. 10 parts of y will give me only one part of x, maybe 1, 2, 3, 4, 5, 6, 7, 8. We need to count it that way. But it is not starting from the center here. You can see it's not starting from the center. If I get an intersection, I can have a perfect counting. But it is here, not on the y-axis. That's why. It means what? When it is aligned here, 10 pieces of 10 of the 10 of the y will give me a change of 1x, in which change of y divided by a change of x is equal to 10. That's the meaning of it. So that part was 6. The slope was here 6, and this is 10. That means this is more steeper. So it keeps away and away from the graph. When we reduce this number 5 here, say when we put it number 1, we are going to make it the slope of 2 times 1, 2. 2 for 1. 2 y changes for 1 exchange. So this becomes more wider. When this becomes more wider, we are going to have two solution sets or intersections. You can try that. Change only this number 5 by number 1, or just like 1 minus x, and do it. Then you will have 2 points here. Or the other option is there. We reduce the slope of this one here on this graph to make it a little bit wider. Just remove this 2, or maybe remove this number 3, one of them. Then the f of x will become also wider. Then we will have two solution sets. It is how the characteristics of the graphs of the absolute values, and a lot more we can talk about. Just one more piece we can talk about, and we end up this discussion. One more piece, very much interesting piece. What about if we combine both sides of this equation as one graph? Which is, we talk a little bit of that one. We can see that. The equation was, if you remember, 3 times an absolute value of 2x minus 4 is equal to, there was a sign is equal to here, 6 minus, it was minus here, minus 2 times in bracket in absolute value 1 minus 5x. It was that. So instead of those two to equate, I collect everything to the left. 3 times 2x minus 4 minus 6 plus 2 times 1 minus 5x. What I have left on the right side is just nothing, 0. Now this graph is just as one graph, h of x, and the other graph, which is x-axis. Is there an intersection point between h of x and the x-axis? That is the meaning of this equation. Nothing is there. You can see the graph starts at about 4.8 y value. The y value is 4.8. If we want to know the x corresponding x, we can put 4.8 here in place of g of x and solve that one. So there is nothing. The graph is there above 4.8. Remember here, this to find out the minimum of this graph. To find out the minimum of this graph, we cannot say that this part and this part to be 0. No, we cannot. Because these two variables are changing together because they are just one function now, h of x. One function. They are part of one expression. So when we make this part 0, we can use, for example, 1/5 here. If we use 1/5 here and we put this one 0, the same 1/5 has to be here. Just I'm giving example, same 1/5. So 1/5 here will make this part 0. Yes, of course. 2 times 0 is 0. Of course, now we have only to subtract 6. But 1/5 here will not make this one 0. 2 times 1/5. It makes it 2 times 1/5, which is 2/5 minus 4. 2/5 minus 4 is negative, but an absolute value will give it positive. I have to multiply it by 3. And I have to deduct 6 afterwards. If I take this one 1/5. So making this one 0 is not necessary to give you the minimum value, or making this one 0 is not necessary again to give you the minimum value. The minimum value is obtained by somewhere here 0.2 in graphs. We only estimate, we cannot be sure. Somewhere around 0.2 of x. X value 0.2 will give me the minimum value of 4.8, and anything else is above. So there is no chance this graph will come down to the x-axis and make an intersection with the x-axis, or no x-intercept. Again, the solution set for this equation is the same one, an empty set. Thank you so much for watching my video today. Have a good day.